Hello, welcome. In this short video, let us look at more examples explaining the concept of causality. Consider a system where we have the input as the initial velocity u of 0 and the acceleration a, and the output as the current velocity v of t. So, by Newton's laws, they are related by v of t is equal to u of 0 plus a into t. The acceleration a is given by the Newton's second law, where F is equal to m into a. That is, the force vector is equal to mass into the acceleration. Here the current velocity is always dependent on the initial velocity and also the acceleration, and it is never dependent on the inputs from the future or the values from the future or the values for tau greater than t. So this is a classical example of a causal system, and we can also plot these values on a Cartesian coordinate plane, that is where the x-axis is given by the time and the y-axis we denote by the velocity v of t. So at t equal to 0 we have the initial velocity u of 0. So at t equal to 0 v of 0 is equal to u of 0. At t equal to tau, as a positive value, v of tau is equal to u of 0 plus a into tau. That is, it is located somewhere over here. It is v of tau, and this is our tau. And the slope is equal to the acceleration a, and the intercept is obviously equal to u of 0. So the value of the velocity at any given time is a function of, or is dependent on the intercept, that is u of 0, that is the input velocity or the initial velocity u of 0, and the acceleration. The next example is development of a hurricane, that is its evolution from its formation to landfall. Basically, at the formation stage, it builds into a cyclone system by interacting with the ocean and the atmospheric systems, and then in the next stages, in the subsequent stages, it basically collects energy in terms of water vapor and also wind speed and momentum from the atmosphere. And then in the next stages, it gradually grows in larger in terms of both size and mass and its angular momentum, and at the final stage it basically reaches the land and makes the landfall, and sometimes it may dissipate as one of the main sources of its energy, that is water, is diminished. Basically there is no water supply on the land, or there is no supply of water vapor on the land. So the main idea in terms of causality is that whatever happens in the late stages of the hurricane is a direct result of the processes that take place in the previous stage. So the properties of the system at any given point are only results of the events and processes that happened before, and it cannot be a property or cannot be dependent on the future events. That's the evolution of a hurricane is a good example of a causal system. Thanks for watching.